Hello everyone, we are discussing alternating current. Write down alternating source with a pure resistor. Pure in the sense means only resistance is present, and then we will see combinations like resistance, capacitance, inductors, all these things are present. Let's talk about pure resistor. This is pure resistor R, and that's how we represent an alternating source. And we have been given that EMF of source is E naught sine omega t. We need to find current in this resistor. Although there is no meaning of this arrow, because when I say alternating current, current is going to change direction. We can say that this direction will represent positive value and the other direction will represent negative value. This circuit at time t is equivalent to this. This is the value of E, this is R, current I is flowing. With this alternating source symbol, we mean that magnitude of EMF is going to change continuously with time, as well as polarity is going to change. So for simplicity, what we have done, we are saying that let's say at time t, EMF suppose is 10 volts. So the value I am writing is just for your understanding. Suppose I say that this EMF is 10. Then maybe at some other time, this 10 becomes only 4. At some other time, this E is minus of 8. So minus of 8 means battery is no longer pushing current in this direction. Instead, you have a battery connected with reverse polarity. So, when I represent the whole thing in this form, it is giving you an idea the way at time t you can understand the whole figure as if you have a battery of E, EMF E, there is a resistance R and current flowing in the resistance is I. If this E changes, accordingly I will change. If this E changes its polarity, accordingly current will also change its polarity. So, what is I in this figure? This is a simple electric circuit. In this figure, I is E divided by R. What is E? E naught sine omega t divided by R, which we can write as R E naught sine omega t. What is I naught? E naught divided by R. Now the important part which we get from this calculation work is something like this. This part omega t, it has a special name. This omega t term, and if you remember oscillations, if you remember waves, then you must be knowing what we call this term. How do we identify this term? We have a special name for this. Let me see if somebody remembers this. What is this term omega t called? Write down this in the comment box. If you know what this term omega t is. In oscillations, it has a special name. What is that special name? I'm not asking what omega is. One of you is saying angular frequency. Omega is angular frequency. I'm asking what is omega t. Because omega t has a special name. And what is that special name? That's the correct thing. The second response is the correct one. This omega t, it is called phase. It has a special name which is what is phase. So, what is the important part and what is the meaning of phase? When you say E, what is E? EMF of the source. But from the point potential technique, you also know this. If this terminal is A, then this is also A. If this terminal is B, then this terminal is also B. What is VA minus VB? VA minus VB means potential difference across the resistor. But what is VA minus VB? E. So, from now on, for this resistance, the argument is if phase of potential difference, what is E? E is potential difference across the resistor. If phase of potential difference across the resistor is omega t, then same phase current is also current flowing through the resistor is also in the same phase. This is the important argument which we gather from this pure resistor connected across an alternating source. What is the meaning of same phase? Can they be in different phases for some other device? We'll see that and you will understand everything. But right now, note down everything and then we'll write few statements. Just note down this much. And if you are not feeling comfortable with phase and all, just don't worry. Things will be clear in 5-10 minutes. So write down the statement. When a resistor is present in an alternating circuit, alternating circuit means where current and EMF, they are of alternating profile. When a resistor is present in an alternating circuit, then phase of potential difference and phase of potential difference across the ends of the resistor. Phase of potential difference across the ends of the resistor is same as that of current, flowing through the resistor. As that of current flowing through the resistor. Now, what is the meaning of same phase? If you have no idea what phase is, then I'll give you an example with the help of these two rods which are going to oscillate. I hope you can see. So if they are oscillating like this, I hope you can see it now. They are oscillating like this. Then this is called they are in same phase. They both reach their amplitudes simultaneously, their mean positions simultaneously, the other amplitude simultaneously, and so on. So when oscillations are like this, you say that both oscillators are in same phase. Later on we'll see that things can oscillate like this also. One is at the mean position and the other one is at the amplitude. When this one arrives the mean position, this one reaches the amplitude. When this one reaches the other amplitude, this one arrives at the mean position, and so on, which will be called oscillators in different phases, the phase difference of pi by 2, but we'll see that later. Right now, when you say both potential difference and current are in same phase, in terms of current and potential difference, it means what? Write down that. Having same phase means when potential difference is 0, current is also 0. And when potential difference is maximum, current is also maximum. When potential difference is maximum, current is also maximum. And let's draw a graph which will make all this thing clear once again. So if I draw a graph between VR and T, this will be your time axis. And similarly, if you draw a graph between current and time, This is potential difference. This will represent your current I. And this is your time axis. Now before you plot the graph, what you will do, you will draw these partitions. At equal interval. What are these time intervals? If you are present in the last class, then you know what these time intervals are. If you know the time intervals, write down this in the comment box. What are these time intervals? This is the graph for V, and same is the graph for I. Not a single reply so far in the comment box. This is capital T, one complete cycle. So all these are T by 4, another T by 4, T by 2, and this one 3T by 4. First is T by 4. Another T by 4 gives you T by 2. Another T by 4 gives you 3T by 4. And right here you have capital T. If you can see these blue lines, they are giving you time values. Time instant, time instant, time instant, time instant. And the graph in the black is giving you VR. Similarly, graph in the black over here is giving you I. So what you can see is when potential difference is 0, current is also 0. When potential difference is maximum, we find that current is also maximum. When potential difference is 0, current is 0. When potential difference is negative, negative means this battery is connected with the reverse polarity. This battery is then operating like this. And if it operates like this, then for us this type of EMF will be negative. If you have a battery like this, then current will flow in this direction. So if this current was taken positive, then this current will be negative. So negative means simply the direction part. So when your EMF or when your potential difference is negative, current also becomes what? Negative. And after capital T, you know that this sine curve is going to repeat itself again. This is the meaning of same phase. Put on this, and if you want to understand the meaning of negative, draw this thing separately. Meaning of negative EMF, meaning of negative current. Put on this much. Okay, only 2% could answer that. Good. Rest of you make a habit of answering something. You do not answer, and therefore the problem is that when somebody doesn't answer anything, maybe one of the reasons may be that they are confused. So if somebody is confused, for example, the first person, when I asked what is the meaning of omega t, he answered angular frequency. So when I corrected him, now he will remember that omega was angular frequency answer is asking omega t. So his answer is not correct, but he is learning something even from this exercise. Now, most of you, you do not answer anything because you think that if your answer is wrong, what others will think. And this way, you do not learn even a single thing. When you start answering questions, you also start learning things. When you start answering things, even if they are not correct entirely, it creates an extra pressure on you that you have to revise things because you'll be answering something. So this extra pressure will definitely improve everything in you. So choice is yours. You can maintain same type of silence, or you can improve your capabilities. But then at the end, don't just tell me that, sir, you did not help us. I did, and this is the first time I'm asking you to answer this way. I've been telling you this thing again and again. Those who are coming from 11, they remember that since the beginning of 11, I've been telling you this part. So let's get rid of the fear of answering incorrect things. Even if every answer you gave is wrong, there is no issue. Throughout the year, every answer you gave is wrong. Even then, there is no issue because you learned something. Those values were not correct. Now forget it and look at the next part, which is pure capacitor. And this will make the concept of phase and phase difference much more clear. Write down the heading, pure capacitor in an alternating circuit. Pure capacitor. Pure means there is no resistance at all. So this is how a circuit looks. E equals V naught sine omega t, and we need current which is flowing in this capacitor. Now, at time t, just as we did in the previous setup, at time t, things are like this. This is the positive terminal, this is the negative terminal, we'll call it E. And some current is flowing in this direction. This will change its value as well as its polarity. And similarly, current will change its direction. So can I do something like this, that I, in the previous part what we did, we divided E with R. So can I divide I For I, can I divide E with C? Yes or no? Write down in the comment box. In the previous circuit, when we had a pure resistor, we did E divided by R. This time we have a capacitor. Can we simply write E divided by C? Well, we cannot, and the reason is it's not dimensionally correct. First, what is ampere? Volts divided by ohms. But this is what? Farad, a different unit. So first thing is it's not correct because of dimensional analysis. And the second is, if somebody is trying to apply Ohm's law as I equals to V by R, then what is V? Potential difference. And what is R? Resistance. Potential difference across this thing is definitely E. But resistance of this thing is not C. That's the reason you cannot write E by C. First part. So we cannot use this. We can use this. Then how do we find current? This is one way of finding current, V by R. And the other method for finding current is, what is I? dq divided by dt. So if this terminal is positive and this plate is connected to the positive terminal, then this is also positive. This is negative terminal and this plate is connected to the negative terminal, then this plate will have a negative charge. So this got plus Q and this plate has got minus Q. Something we have already done in capacitors. You have a battery, positive plate has got plus Q charge, negative plate has got minus Q charge. Positive plate means the plate connected to the positive terminal, negative connected to the negative terminal. When after some time its polarity will reverse, this will become positive and this will become negative. But let's use the same logic which we did in the previous case. If this is A and this is B, what is A? Potential of this terminal. It's a plain wire and point potential technique says this is also A. If this is B and you have a plain wire, this is also B. That means what? If I ask you what is VA minus VB, then it means it is VC. What is VA minus VB? That will be called potential difference across the capacitor. But what is VA minus VB? E. This is E. But what is VC? What is VC? What is potential difference in terms of charge and capacitance? Write down in the comment box. What is potential difference across a capacitor in terms of charge present on it and its capacitance? And I hope you will write Q by C. What is VC? Q by C. This is something which is coming from capacitance. What is E? E naught sine omega t. This gives us Q as C naught sine omega t. Q is coming C E naught sine omega t. This C E naught, if you wish, you can call it, you should write under this line. Let's say C E naught is Q naught. What is Q naught? Maximum value of charge. This is Q. C E naught sine omega t. The only thing which you can change is what? Sine omega t. When is sine omega t maximum? When omega t is 90. What is that maximum value? 1. So this is 1, this becomes C E naught. Q will be maximum. That maximum value has been called Q naught. This is Q, which is Q naught sine omega t. You know how to find I. You've got Q, differentiate this thing and write down what do you get after differentiating Q with respect to t in the comment box. And in the last class itself, I taught you how to differentiate sine functions. Let's see how many of you can differentiate this with respect to t. And write down the answer in the comment box. Good, most of the answers are correct. How do you differentiate it? C naught is a constant. Differentiation of sine is what? Cos. Since differentiation is with respect to t, bring this omega out. This is a differentiation. C E naught omega cos omega t. Everybody is correct. Some of you just took a negative sign. So remember, differentiation of sine is what? Plus cos. Now, this I, let's represent this I in this new form. You will write down after this. I am writing over here. This is E naught divided by 1 upon omega c sine of this is cos theta. I want to convert this cos theta in terms of sine theta. Why? So that I can find phase difference with this part. What is EMF? Sine omega t. So what is phase of potential difference? What is phase of potential difference? Omega t. So I just want to keep omega t over here. Let me help you further. I want to write omega t, but after omega t I should write something so that this and this, they are same. So what should I write here? Give me the entire bracket, or you can use sine of. This is something which is taught in, I suppose, 10th or 9th. So you can answer this. Let's see how many of you. Well, I is C naught omega cos omega t. This is sufficient. But we want to represent current in terms of this phase. And therefore, I'm asking you what should come here. And why we did this, I'll explain that. But tell me, what should I write here? How should I complete this part? Good. 4 or 5 people try to answer this thing, and the answer is entirely correct. And I was expecting this from you. What is sine of 90 plus theta? And the answer is cos of theta. Everybody knows this. Sine 90 plus theta is what? Sine 90 plus theta is cos of theta. So, this part is I equals to E naught divided by 1 upon omega c sine of, if I do this, if I write omega t plus pi by 2, what is 90? Pi by 2. Better way is to write pi by 2 in terms of radian and all. This 90 is what? Pi by 2. I hope everybody knows this. So E naught 1 upon omega c sine omega t plus pi by 2. This is same as this. So when I asked you what should I write here, then this part should be omega t plus pi by 2. Sine of 90 plus theta is cos theta. What is theta? You get the same thing. But now look at the advantage. But first let me ask again as usual. Who will tell me the unit of 1 upon omega c? What is the unit of this term 1 upon omega c? Who can tell me this? And all these things, you can expect these things in any objective examination. What is the unit of 1 upon omega c? A simple question like this. What's the unit of 1 upon omega c? The first unit is 1 upon, what is the unit of omega? Omega is radians per second. Angular frequency. What is the unit of c? C is farad. So what is 1 upon omega c? 1 upon omega c is this. But only one person has answered and the answer is correct. What is I? Amperes. What is the unit of sine? It's a ratio, perpendicular upon hypotenuse. It doesn't give you any unit. So what is I? Amperes. What is this? Volts. So what should be the denominator? Ohms. And therefore this thing is nothing but ohms. What is 1 upon omega c? Ohms. That means 1 upon omega c is nothing but resistance. But resistance offered by a capacitor. 1 upon omega c is what? Ohms. That means it is offering us resistance, and the resistance is being offered by the capacitor. This RC is represented not with the help of R but with the help of XC, which is called reactance of the capacitor. Reactance of the capacitor. Don't worry about reactance. What is reactance? Resistance offered by the capacitor. Note down this and then we'll write a few statements. First, note down this much. Just first write down this I as I naught sine omega t plus pi by 2, where I naught is E naught divided by xc. That's how, in short, you will remember this. What is I naught? E naught divided by this. This thing has a name which is xc, and this sin omega t plus pi by 2. And just so that you can understand what was VC, VC was E. That means what is VC? E naught sine omega t. I hope you can see the difference. This time, phase of potential difference across the capacitor is omega t, whereas phase of potential difference, phase of current through the capacitor is omega t plus pi by 2. So this pi by 2 part shown in red, it gives us phase difference. Also note down this, the whole thing at one place. The whole thing at one place. This is something which we obtained from the whole calculation work. That's what we are interested in. The thing which you see in blue, it's called phase. Phase of potential difference is omega t. Phase of current is this. What is pi by 2? Phase difference. Now write down the statement. When a capacitor is present in an alternating circuit, when a capacitor is present in an alternating circuit, potential difference across the plates, and current flowing through the capacitor are not in same phase. Are not in same phase. A phase difference of pi by 2, a phase difference of pi by 2 radians inside the bracket 90 degrees is present between I and V, current and potential difference. And we say that This is the important part, and we say that current leads the potential difference leads the potential difference by pi by 2. Current leads the potential difference by pi by 2. What is the meaning of it leads? First of all, when you say we have a phase difference of pi by 2, it means this. The setup is no longer like this. They are not in same phase. This time, this is happening. One is at the amplitude, other one is at the mean position. And so on. And you will understand it better once you draw the graph. So, I'm giving you 1 minute's time. The same way, plot V and I for a capacitor. Show the partitions at T by 4. I'm giving you 1 minute's time. And after 1 minute time, I will draw the whole thing. And if you have done the same, then you will write yes in the comment box. Make partitions. Draw a graph of V versus T, then I versus T. And then tell me whether you did the same thing or not. So let's see if you have done the same thing or not. This will be VC. And this is IC. Current which is flowing through the capacitor. And these are the partitions. And that's how you plot the graph. VC, it is this. What is VC? VC is E naught sine omega t. What is I? I is I naught cos omega t. So we are drawing a graph of cos, and I hope you know how to draw a graph of cos. That's how a graph of cos is plotted. So if you have done the same thing, then write down yours in the comment box. And these are peak values. This one was E naught maximum. This was I naught. For this, we are using I. For your understanding, I have written I as I naught cos omega t. This place is I naught. This place, it's quite clear, it will be minus I naught. This is E naught. This will be minus E naught. Four or five people are saying they did the same thing. Good. Now we'll write the statement, but before that, let's understand the meaning of this phase difference of pi by 2. Look, this is the maximum potential difference. When potential difference is maximum, current is 0. When potential difference is 0 across the plates of the capacitor, current is what? Maximum. This is called phase difference of pi by 2. Write down the statement. When a capacitor is present in an alternating circuit, when a capacitor is present in an alternating circuit, phase difference of 90 degrees means phase difference of 90 between V and I means when potential difference, to be more specific, write down potential difference across the plates. Potential difference across the plates is 0. Current through the capacitor is maximum. Current through the capacitor is maximum. And when potential difference is maximum, and when potential difference is maximum, current is 0. Let's see how much you are comfortable with all these things. Can you tell me what is phase difference between charge and potential difference? What is the phase difference between charge and potential difference? Let me see how active you are. No reply. At least one person has answered. Let's see if his answer is correct or not. Others. I told you should try always. You cannot simply stay mute like this. I'm asking phase difference between Q and V. So what was Q? Q was CV. We started from this. V means potential difference. What is this? VC. What is VC? VC was what? E. VC is E, which is E naught sine omega t over here. What is Q? Capacitance times VC. What is VC? E. What is E? E naught sine omega t. But I hope you remember that I wrote this as Q equals to Q naught sine omega t. What is the phase of charge? Phase of charge is omega t. What is phase of potential difference? Omega t. They are in the same phase. What is phase difference? 0. That's how you can expect questions in competitive examinations. This 90-degree part is being asked most of the time. So you can expect a different thing like this. What is phase difference between charge and potential difference? Potential difference is basically because of charge only. This is the formula for Q, C and V. That's how you relate it. C is constant. If C is constant, then it means that as you increase V, charge will also increase. So they are in the same phase. Write down this. But charge and potential difference are always in the same phase. Are always in the same phase. That is, phase difference between Q and V is 0. And this will, I will just take one more minute. This will clear everything in this part. Why do we observe a phase difference? Let me give you the logic behind this. So you can see that when VC is max, Q is also maximum. When Vc is max, Q is also max. They are in the same phase. So look at this capacitor. It has got charge Q and it has got charge minus Q. At one point you are saying that this Q is Q naught. What is Q naught? Maximum. And this minus Q is minus Q naught. So the capacitor has got maximum charge. If it has got maximum charge, that means it does not want any further charge on it, because you are saying charge is maximum. It is not going to accept any more charge. So if it is not going to accept any charge, that means there will be no flow of charge. If there is no flow of charge, that means your I, rate of flow, there is no flow. So what is I? 0. So when charge is maximum, V is maximum, but I is what? 0. When V is maximum, I is what? 0. Do you understand this logic? Yes or no? Write down in the comment box and then you can leave. Thank you very much.